All right, so section 8.2 is on graphing simple rational functions. And the word simple is somewhat of a misnomer, so this section has the tendency to be a little confusing because we're now going to take a look at rational functions in which we have some variable in both the numerator and the denominator of our fraction. Again, rational implies that we have a fraction, and so by having a rational function, now we're going to have x's on top and on bottom. So we've got some work to do today. Again, take some good notes here, and hopefully this will make good sense to you. All right. So the first thing is a rational function is a function in the form f of x equals p of x over q of x, where p of x and q of x are polynomials, and q of x can't be equal to 0. And again, it's pretty obvious that q of x can't be equal to 0 because if it is, we get a 0 in the bottom of our fraction, which, as you know, is undefined. Okay? So let's take a look at some simple rational functions and talk a little bit about this idea of the parent function for a simple rational function. All right? Parent function for a simple rational function is any function f of x equals 1 over x. The shape of this thing is called a hyperbola, and it consists of two symmetrical parts, and those two parts are referred to as branches. All right? Now, the domain and the range are all non-zero real numbers. So the domain is all values of x that are not equal to 0, and the range is also all values of y that are not equal to 0. So my graph can never be equal to 0, no matter what. It's going to have an asymptote at x equals 0, and an asymptote at y equals 0. And an asymptote is simply a value for x or y, a horizontal or a vertical line that my graph is going to get very, very close to but never actually touch. All right? Any function in the form g of x equals a over x, so such that a is not equal to 0, has the same asymptotes, domain, and range as the function of f of x equals 1 over x. So basically, as long as we just change the top number here to something other than 1, it's going to have the same domain and range. Now, we're going to get into our h and k again in just a little bit here, so that's going to be moving our function, but let's get an idea of what this thing looks like. So, a very quick sketch of a hyperbola would look something like this. On my y-axis and my x-axis, I would have this graph that kind of gets really, really close to the y-axis, but because my domain or my range rather, is undefined for values of y that are equal to 0, I'm going to get something that looks kind of like this. And I will say that the right way. The domain cannot be x equals 0. All right? And so we're going to get this asymptote at the vertical line x equals 0. And so my graph is going to get very, very close to x equals 0 as it continues to go higher and higher, but it'll never actually reach it. Same thing as we go out here, as we move to positive infinity in my x direction, my graph is going to get very, very close to the x-axis or the line y equals 0. It's going to get really, really close to it, but it's never going to actually touch it. Now, that's one branch of the hyperbola. There are two branches, and so because it's symmetrical, you're going to get something that looks like this on the other side. All right, so this is a sketch of something called a hyperbola, and again, you can see the two symmetrical branches. And as we said before, my function is undefined for y equals 0 and x equals 0. All right, so there is no restriction on x and y such that x and y are just basically not equal to 0. All right, so let's take a look at how this actually plays out here. Let's go ahead and look at a function. All right. So the first thing we're going to do is we're going to graph the function y equals 4 over x. All right, and we know because this thing has, because it's of the form y equals 4 over x, we know that I'm going to have an asymptote at x equals 0 and y equals 0. All right, so I'm going to have an asymptote here at y equals 0. I'm going to have an asymptote here at x equals 0. All right, remember, vertical lines say x equals, horizontal say y equals, so it might be a little confusing while I'm drawing a line on the y-axis and saying this is x equals 0. It is, okay? All right, so let's plot some points to the left of this thing, and what we're going to do here is we're going to use our graphing calculator, and we're simply going to plot those points in our graphing calculator. All right, so to get this rational function, we're going to put 4 divided by x, and we're going to make sure that I'm on a standard size window. It looks like I am, and so we'll go ahead and we'll take a peek at that graph. And again, as I said before, here's your hyperbola. We've got that kind of two branches to that hyperbola, and let's slide this thing over here so that we can see our notes as well. Okay. All right, got everything back on top like I wanted. All right, so we need to plot some points to the left and to the right of this thing. So let's put some points on the left-hand side of our vertical asymptote. All right, and so we're going to go back over here. We're going to go to second table. And again, you'll notice here when x equals 0, what's y? Well, that's equal to an error, right? So obviously that's our vertical asymptote. When x equals -2, you can see here that y equals -2 as well. When x equals -1, we get -4. When x equals 1, we get 4, and we get 2 here. All right, so -2 is like down in here someplace. All right, -1, -4 is like 1, 2, 3, 4 down in here someplace. And we could go out further here if we wanted to. We could go out to like -3, and we get -1.3 repeating, which is not a very nice number. -4, -1 is certainly a good number that we could plot. So we'll go out here to -1, 2, 3, 4, and -1. So I've got a few points here, and I know that this branch of this guy is going to look something like this. All right, the other side of that, when x is 1, y is 4. So 1, 2, 3, 4. When x is 2, y is 2, and when x is 4, y is +1. If you don't believe me, we can fly over here to my chart here. Sorry, my calculator's lagging just a little bit here today. And when x equals 4, y equals 1. And so now you're getting the other branch of this thing, which is going to look something like this. All right? So again, it says draw the branches of the hyperbola so they pass through the plotted points and approach the asymptotes. Again, they're never actually going to reach this vertical line or this horizontal line, because they are my asymptotes. Okay, so that's my first hyperbola. Pretty simple in terms of a rational function. Okay, now let's take a look at a checkpoint problem. Why don't you guys try this first checkpoint problem, and we'll see how we do. All right, so we're asked to graph the function y equals 3 over x, and that's kind of under my calculator here, so I'm going to rewrite it over here. And so let's put 3 over x and go ahead and graph it. As we know, we're going to have asymptotes at 0 and 0, the x equals 0 and y equals 0. And so let's make a table for this guy. When x equals, and let's just pick some points. When x equals -1, we have -3. So -1, -1, 2, 3. And I'm sorry, I probably should have drawn in the asymptotes. I'm going to pick a different color here, and I'm going to draw in my asymptotes, my horizontal asymptote and my vertical asymptote. Sorry, I kind of missed the lines, but you get the idea, right? All right, so let's go back to my blue here, and let's plot our points. -1, -3 is -1, -3. -2, -1.5 is like right in there someplace. And again, you can pick some other points further to the left, but you know, if x is like say -3, we're going to get like -1, I think, something like in there. I'm sorry, right there. And so you're going to get something that looks something like that. All right. And again, you can write the points down. You can just use your calculator to get those values. When x is 1, y is 3. 1, 2, 3. When x is 2, y is 1.5. So 2, 1.5. When x is 3, y is 1. 1, 2, 3, up to 1. And again, you've got your asymptotes at the x and y axes. And so there's your hyperbola. Okay? All right. Let's go back to our old buddy h and k. Graphing translations of simple rational functions. To graph a rational function of the form y equals a over x minus h plus k. Remember how we've talked about this in pretty much every chapter all the way through Algebra 2. This affects the function in the horizontal direction, and again, it always affects it opposite. And so this moves the graph left or right based on the value of h. This moves the graph up or down. Now, what we're really moving here, if this is my x and y axis, before I used to have an asymptote here and an asymptote here. What this h and k are going to do is they're going to reload my asymptotes. So we're going to draw my asymptotes at x equals h and y equals k. All right, then we'll plot points to the left and the right side of the vertical asymptote. And I'll spell that correctly. There's only one S in asymptote. And then draw the two branches like we did before. Okay? So basically, we just move the vertical, the vertical asymptote, whatever h is. We move the horizontal asymptote, whatever k is. All right, so let's try a simple rational function that's a little bit less simple, but something familiar with what we've done in the past. Okay? All right, so the first thing we're going to do then is we're going to draw our asymptotes in here. This is y equals -6 over x plus 3 plus 2. This plus 3 is going to move my vertical asymptote 3 places to the left, because again, it's opposite, and my horizontal asymptote up 2 places. So again, I'm going to switch colors. I'm going to draw in my horizontal and vertical asymptotes. I should have a vertical asymptote at -3. Now, they're counting by 2s here, so pay attention to that. So we're going to go left 3, which is left 1.5 spaces. And then my y asymptote, my horizontal asymptote, is at y equal 2. All right? So we've now moved our asymptotes to there. And my branches of my hyperbola are going to be on either side of that. All right? So now we're going to go back over to our calculator, and we're going to plug this thing in. Now, you got to be careful with parentheses here. We want -6 divided by, and we have to put parentheses in around this. This is x plus 3 to tell it to keep the x plus 3 together on the bottom, and then add 2 to the whole thing. And let's take a peek at the graph. Okay? Again, you're going to get asymptotes here, and it's kind of hard to see where the asymptotes are, but if you look back at our picture over here, you can see that my asymptote should be at left 3 and up 2. So if I go 1, 2, 3 to the left right here, again, I'm going to get that vertical asymptote, and up 2 is like right in here someplace, and again, that's where I'm getting the right asymptote. So life is good. All right, let's go ahead and get some points from our table here. And so my vertical asymptote is at -3, so I've got to pick some points up here. Once again, when x is -3, I get an error. That's a good thing. So let's go like -4, 8. And so you can see now why they counted by 2s here, because we're going to run out of space in a hurry. At -4, we're at 8. So there's -4. We're at 2, 4, 6, 8. At -3, we have our error. I'm sorry, I got to go the other way. -5, we should be at 5. So -2, 4, 5, up 2, 4, 5. And at -6, we should be at 4. So -2, 4, 6, and up 2, 4 right in there. All right, and so there's your one branch of our hyperbola. All right, the other branch of that is then going to be on the other side of that. So when x is -2, y is -4. So there's 2, 4 right in there. When x is -1, we're at -1, so -1, -1. 0, 0 actually. Okay, that works. And then we can continue to the right some more, but that kind of gives us enough points where we can sketch in that hyperbola. All right, so I didn't kind of fill in that stuff, but I guess you guys kind of get it. We're just pulling these points, -6, 4, -4, 8, and so on and so forth. And I don't know what this one is, but you guys get the idea, right? Okay, why don't we take a look at another rational function, all right? And I want to kind of take a look at this other idea of graphing this idea of this rational function, where now we have some expression in the top and in the bottom, all right? Okay, I want to talk a little bit about this idea of the asymptote. First of all, our vertical asymptote is still going to be at x equals 1. All right, because of the x minus 1, we're going to have a vertical asymptote at x equals 1, because if x are equal to 1, 1 minus 1 is 0, and we would get a undefined situation. So we're going to have our vertical asymptote here. All right, now I want to talk a little bit about our horizontal asymptote. My horizontal asymptote comes from the idea that as x approaches infinity, as I continue to go out here to the right, as x approaches infinity, b and d are constants. Those are going to be pretty much irrelevant. So as x approaches infinity, we get to very, very large values of x, b and d pretty much become irrelevant. And so the y value becomes a over x over c times x, all right? And then x divided by x just basically cancels out. So my horizontal asymptote will be at y equals a over c. All right, and so that's where they kind of came up with this formula. They said, look, the horizontal asymptote is at y equals a over c, and it's because this b and d basically become irrelevant as x approaches infinity, positive infinity. All right, and so my a value in this case, my a and my c, my a is 4, my c is 1, and so this becomes 4 over 1. So I get a horizontal asymptote at y equals 4. So there's 1, 2, 3, and 4. All right, so those are my two asymptotes. All right, and so now we just want to pick some points to the left of that and some points to the right of that. All right, so we're going to go back over to our graphing calculator. We're going to type that function into our graphing calculator. So we're going to have to be real careful with parentheses again. This is parenthesis. Let's just clear it out. Parenthesis 4x minus 2 divided by parenthesis x minus 1. And let's take a peek at the graph. As I said before, you're going to have a horizontal asymptote at 4, and you're going to have a vertical asymptote at 1. according to what I can kind of sketch here. Here's 1, 2, 3, and 4, so I should have a horizontal asymptote somewhere in that region right there, and I should have a vertical asymptote somewhere about right in there, and that looks pretty good, right? So let's get rid of those two little pieces, and let's take a peek at my table. Okay. We want to pick some values to the left and to the right, and so my vertical asymptote is at positive 1, so let's pick some values to the left of that, like negative 1 and 0. Okay, so here are the points they've chosen when x equals negative 1, y is equal to 3 right there. All right, and when x equals 0, y equals 2, and so we put that there. So negative 1, 3 is left 1, up 1, 2, 3, and then 0, 2 is 0, up 2, which is right in there. And it's kind of hard to use those 2 points to make a branch of a hyperbola, but if you go back to the graph, you know that this is going to be kind of something that's going to be somewhat in this region here. All right, but drawing in the asymptote certainly helps us so that we kind of know what our boundaries are. All right, so let's pick some points to the right side when x equals 2, y equals 6, and if you move down in your chart, which you guys can do, I'd have to switch modes to do that, so y equals 5, and so over 2, 1, 2, up 1, 2, 3, 1, 2, 3, 4, 5, 6, and when x is equal to 3, 1, 2, 3, y is equal to 1, 2, 3, 4, 5, and so you get something that's kind of like that. And again, we're not looking for this to be perfect, we just kind of want to get basically where are the asymptotes in. All right. Now, I think it's important to recognize over here, and I didn't do this on the last one, so we can certainly address that at a later time, but I want you guys to kind of think about the domain here. The domain of this thing is x is all real numbers except what? Well, we can't be equal to 1 because that's my my asymptote. And the range is all y is all real numbers except 4, because again, my horizontal asymptote was at 4. All right. So since I had a horizontal asymptote at 4, that says that the y values will be anything except for 4, because right here I have an asymptote at 4. All right. So I think you guys are down to a checkpoint problem now. 2 checkpoint problems, and that'll conclude the lesson. So try these 2. We'll be right back with solutions for you guys. Okay. All right, so my first one's straightforward here. We've got a vertical asymptote at x equals 2, so we're going to go over here to 2. We're going to do our vertical asymptote in. And since it says y plus 1, that moves my horizontal asymptote up 1 unit. And so here's my horizontal asymptote there. All right. Okay, so now what we have to do is we have to go back to our graphing calculator and we have to type in this function. So let's grab our graphing calculator. Let's go back to here and let's type in our function. Our function is 3 divided by parenthesis x minus 2. And again, if you don't put this parenthesis in here, it's going to do 3 divided by x and then subtract 2. We want the x minus 2 all in the denominator of the fraction. Right? Now, you can kind of see that your hyperbola here, your branches are going to be, on the left over here. So I have this kind of branch here and this kind of branch here. And so that's kind of the general shape we want over here, but we can't quite graph that yet. Let's go ahead and use our table feature. And let's plot some points. To the left of this thing is things like 0 and 1. And so when x equals negative 1, y is equal to 0. Okay, negative 1, 0. When x equals 0, y is negative a half. So 0, negative a half. When x equals 1, y is negative 2, and so that's right down in here. And that should be enough points to get you that general picture there. And again, that kind of matches this shape that I drew here before. Now, I can't see enough here, so I'm going to have to go back over to my other mode and slide down. And let's go back over here. Now, when x is equal to 3, y is equal to 4. So 1, 2, 3, up 1, 2, 3, 4. When x is equal to 4, y is equal to 2.5. So 4, 1, 2.5. When x equals 5, y equals 2, and so on and so forth. That gives you that picture there. Now, this may seem a little bit tricky because on the bottom we have this negative x minus 2, which we've never had before. What we've done in the past is we've basically said whatever this number is, it's the opposite of that. But here's the thing, this is a little tricky here because of that negative out in front, right? So what we really want to do is say what value of x makes this thing equal to 0. Okay, well add 2 to both sides. You get negative x equals 2, divide both sides by negative 1, and x equals negative 2. So if x is negative 2, this becomes negative of negative 2 minus 2. Minus and minus becomes plus, and so positive 2 minus 2 is 0, right? So if x equals negative 2, that causes the bottom of this thing to be a 0. All right? So we kind of have to be a little careful with that. My vertical asymptote now is at negative 2. All right? Now I'm going to clear some of this stuff out of here now. Now that we know where our vertical asymptote is at. And let's go ahead and take a peek for our horizontal. As we know, our horizontal asymptote is at a over c, or basically negative 2 over negative 1, which becomes positive 2. So I should have a horizontal asymptote at 2. All right? So now the branches of my hyperbola are going to approach those two values but never actually reach them. All right? We need to plug these into my graphing calculator so that I can get some values for them. Okay, so I'm not even going to bother looking at the graph right now. I'm just going to go ahead and look right at the table. All right. I know that I've got a vertical asymptote at negative 2, and so according to these values, when x equals negative 2, I've got a bit of an issue here. All right. So let's take a look then at some of these other values. So when x equals negative 3, y is equal to 7. So negative 2, 3, and then 2, 4, 6, and 7, something like right in there. When x is negative 4, I'm at 4.5, so negative 4 up to 4.5, something like in there. When x equals negative 5, I'm at positive 3.6, so yeah, right in there someplace. Either way, there's my branch. Okay. On the other side of that, when x is negative 1, so left 1, I should be down 3. So that's like right in there somewhere. When x is 0, y is negative 0.5, so like right in there someplace. And when x is 1, y is 0.3, so yeah, right in there someplace. In either case, you kind of get the idea. There's your branch. All right, so use the graphing calculator to get your points for that thing. Again, this is a little tricky down here on bottom because it's not actually just the opposite. So basically set the bottom equal to 0 to find your horizontal asymptote, your vertical asymptote. Your horizontal asymptote becomes a over c. All right, and so that concludes that lesson, lesson 8.2.